What we've got here is the 2019 Paper 1, Question 5 from the higher paper. This question focuses on vectors in three-dimensional space. Now it's got two parts to it. First part, I want to take these 3 points and show that they're collinear. The second one, I then want the vector A to C, and I want to state the ratio where the point B divides that in. So what we're going to do is we're going to start with this first part about showing that they're collinear and taking it from there. Now, what we have to do is find vectors that represent journeys between these ones. So I need to find vectors that represent a journey A to B, or B to C, or A to C. So I need to find two of these vector journeys that share a common point. If I can find two of these vector journeys that share a common point and show that they're multiples of the same base vector, what I've then got is a set of collinear points because they're parallel to one another and they share that common point. So they're all collinear. So let's imagine I take the vector A to B. What that is the point B, take away the point A, representing vector space. So that'll give me 4 take away 1 for the x component, which is 3. -1 take away 5 for the y direction component, which is -6. And 0 take away -3, which is then 3. What you'll notice is that this can be written as 3 times the vector 1, -2, 1. Now that's going to come in handy in a moment. If I then find the vector B to C, that would then be the same as doing the C minus B, written as vectors. So that would be 8 take away 4. That gives me 4. -1 take away -1. So -9 take away -1 is -9 plus 1, which is -8. And then 4 take away 0, which is 4. Now if you look at this, I could take out a common factor of 4. And what I'll then have is 4 times 1, -2, 1. So I've got the same base vector here for both of them. They're just scalar multiples of each of these. So what that allows me to say is that therefore A to B is the equivalent of 3/4 of B to C. So now what I'm able to say is that the implication coming from that is that AB and BC are parallel. Due to the fact that they're both multiples of this vector. So parallel. But what they also do is they have a common point of B. So because they're parallel, and because they share that common point B, therefore A, B, and C are collinear. So A, B, and C are collinear. This bit here is the important part, this communication at the end. We have to explain fully why we are jumping to that conclusion that they're collinear. We have to explain that the two vectors are parallel to each other because they're multiples, scalar multiples, of the same base vector. We also have to state that they share a common point B, so because they're parallel and they have that same point between them, they must be collinear. It's like if we prove 3 points in two-dimensional space lie on the same line. We find the gradient between two, we find the gradient between another two, making sure that they share a point somewhere. Because they all share the same gradient, they're parallel, but because they also share the same point, they must be collinear. Same thing here in three-dimensional space. Second part of the question was state the ratio in which B divides AC. Well, because AB is the equivalent of 3/4 of BC, we know straight away that the ratio is 3 to 4. For part B, that doesn't require much more explaining than that. Question says state the ratio, we state the ratio. This sort of question here, relatively common. So this is ventured into three-dimensional space with collinearity. We sometimes see 2D as well, as I explained with the points on a straight line. Question like this, so this first part is worth 3 points. First would be for finding your first vector, whether that's AB, BC, or AC. Second part would be finding the second vector and comparing it. So it would have to be this whole stage here, showing that A, B and B, C are related somehow as multiples of each other. Then the third mark comes from this communication stage. You must include about them being parallel, you must include them about them having this common point B, and then you must include the conclusion that therefore they are collinear. And then the last one has just a single mark for stating it divides it in the ratio of 3 to 4.